Going on, guys? In this video we are going to see an example of transient analysis, and in this particular problem we have asked to find out v of t. Now let's look at the question first. The switch has been open for a long time. At t is equal to 0 the switch is closed. What is the voltage across the capacitor v of t? Now to find the v of t we are going to use this equation. V of t is equal to vc of infinity plus vc of 0 minus vc of infinity times e power negative t over tau. Now, in order to solve this problem, we had to find out these three things: Vc of infinity, Vc of 0, and also we had to find the time constant tau. Okay, let's note this one down here. First, we had to find Vc of infinity, and we had to find Vc of 0, and then we had to find tau. These are the three things required. Now, we always start with Vc of 0. That's the initial condition. Now to find this one we have to look at the information. In the question they have mentioned the switch has been open for a long time. So at negative infinity to 0 this is going to be opened. So if it's open for a long time it means there's no current, like there's no charge in this, right? So if there's no charge there's no voltage. So voltage is 0 at the initial condition. So this we have taken care of this part. Now let's see what happens when Vc of infinity. After time is equal to 0 this switch is closed. At time is equal to 0 this is closed. So if it's closed and at infinity, what's going to happen is this capacitor is going to be fully charged. If the capacitor is fully charged, this is going to act like an open circuit, so we won't have this part. This part will be eliminated. Now we have to find out what's going to be the voltage across the capacitor. If it's open, we are going to have open circuit, like let's say we have we are going to have circuit until here. Okay, let's say AB. Now it's open, and if we calculate this VAB, that's going to be the voltage across the capacitor. Now we can say VAB is equal to VC of infinity. Now to calculate VAB, what we can do is we can look at the resistor here, that's 4 ohm. If we find out what's the voltage across this resistor, that's going to be the VC of infinity. Now to find this one we can do the voltage division equation, that is 4 times, let's say 15 times 4 over the total resistance, 4 plus 8, because this is going to be in series, right? This is in series, so 4 plus 8, and we are going to have 15 times 4 over 12. So this is 3, this is 1, so this is going to be just 5 voltage. 5 voltage is going to be Vc of infinity. Now we have taken care of this part. Now we have to find the time constant, and if you remember, time constant is equal to R equivalent times capacitance, right? Now to find the R equivalents we have to think like what's going to be the resistance seen by this capacitor, what's going to be the Thevenin resistance seen by this capacitor. To do that, what we are going to do is we are going to short circuit this voltage source, and if we short circuit, this 8 ohm and this 4 ohm are going to be in parallel. When we have voltage in parallel, we can find the equivalent resistance by this formula: 8 times 4 divided by 8 plus 4. 8 times 4 is going to be 8 times 2 is 16, 32. 32 divided by 12, and if you calculate this value you should get 2.667 ohm. So this is going to be our equivalent resistor. Now we can go ahead and find our time constant. To find this one we are going to multiply 2.667 with the given capacitance, that is 0.4 farads. So 0.4 here, and if you calculate this one you should get 1.00667. So this is our time constant and the unit is second. Okay, now we can go ahead and find our final answer. So let's write our final answer. Vc of t is going to be equal to Vc of infinity. Vc of infinity is 5 plus Vc of 0 is 0, so this is going to be 0 minus Vc of infinity, that's going to be 5, times e power negative t over tau. Tau is 1.0067 second. Now if we simplify this one, this is going to be 5 minus 5 e power negative t over 1.0067, and if we take the 5 common, this is going to be just 1 minus e power negative t over 1.0067, and that's going to be our final answer, time voltage, and that's going to be our final answer. I hope this helps. Thanks for watching.